So now we're going to keep going, and we're going to take a look at actually what do we do if we have prefixes that don't match, or if we need to get back to base units. Because when we measure mass, it needs to be in kilograms, because later we're going to see derived units that depend on that. A newton is the amount of force required to accelerate a kilogram of mass. So we always, I'm going to say always, we pretty much always want mass to be measured in kilograms. Balance is measured in grams, so we have to be able to move between grams and kilograms. Distance, we pretty much always are going to want in meters. Sometimes it doesn't matter, but sometimes you're going to measure something in centimeters. So you have to be able to convert centimeters to meters. And of course, time, we measure everything from minutes to hours to seconds, and usually we want time in seconds. So we got to figure out how do we go between distance in centimeters to meters, or mass in grams to kilograms. Okay, and so if I just say how many meters is 18 centimeters? Question mark meters.
Okay, I shouldn't have to think about this. I should just say, okay, 18 centimeters. I know there's 100 centimeters in a meter, so I'm just going to divide by 100 and get 0.18 meters.
Exactly. Since centi is 100, this is 18 hundredths of a meter, which is 0.18 meters. Okay, that's good enough. You don't need to show me any work. You can just go, oh, I know 18 centimeters equals 0.18 meters.
If you do want to show some work, if you're not quite comfortable there, 100 centimeters equals 1 meter. Okay, so then 18 centimeters. Call this multiplying by the well-chosen 1.
And she says the well-chosen 1 because what she did was she divided both sides of this equation by 100 centimeters, which leaves us with 1 equals 1 meter per over 100 centimeters. Okay.
You're equal.
Right. Those two quantities are exactly the same thing. 1 meter equals 100 centimeters. Now, what we do now is we look at just the units. What's left when we do this division?
Got rid of my centimeters. I got meters, so still 18 divided by 100
is 0.18.
Now, you don't have to show this, but
this
if
is
you're
too much
watching,
work.
great.
Right? If you can't remember that there's 100 centimeters a meter, we have bigger problems. But you don't need to show me this work. If you need to do it, that's fine. Okay. Similar process if we wanted to go from grams to kilograms, say, and so like if you put a mass on a balance, it might say 37.2 grams. Okay. And then you're going to want to do a calculation with that, and you're going to want that in kilograms. So how do we get to kilograms?
Okay, well, I have memorized that there's 1,000 grams in 1 kilogram. So on this one, I'm going to divide by 1,000, or move my decimal over 3 spots, 0.0372 kilograms.
Right. Always stop to make sure your answer makes sense. Okay? I want you to look at what this unit says. 1,000 grams equals 1 kilogram. A kilogram is 1,000 times bigger than a gram. Okay? So if our unit is getting bigger, our number should be getting smaller, because these two things need to be equal.
If I ended up with, that would have been 37,200 if I would have moved backwards. That doesn't make sense, because remember, a kilogram's big and a gram's just a little tiny paper clip.
So we're going to need more grams than kilograms.
So that looks like it's equal.
Yeah, those are equal. That looks good. Okay, so let's say we had, what, 1,000 or 1,200 or 1 point, here's 1,200 micrometers.
Now, micro is one I automatically have memorized, so I'm going to look in my book. My book tells me that 10 to the negative 6 meters is 1 micrometer.
Okay.
How'd I do?
Well, I won't comment on your handwriting. But, okay, 10 to the negative 6 meters equals 1 micrometer. So basically what we're just saying is this prefix micro equals times 10 to the negative 6th. So all you have to do is make that substitution. 1,200 times 10 to the negative 6 meters. Now it's in scientific notation, sort of. I know it's not technically correct. I don't care. This is the number you're going to use for your calculation anyways. You can plug that into your calculator. Everything's all good.
Right, and we will give you this number times 10 to the minus 6th. So
yeah,
you just take your number and add the...
Right. Okay. Now, time. Okay. Time is a little bit different because it's not just powers of 10. It's not just moving decimal points around. Okay. If I had 36 well, let's go the other way. Let's say I have 1 hour. Okay, we almost never want time in hours. We usually want time in seconds. How do I get from 1 hour to seconds?
It's pretty, I mean, we have that intuition. We know things like there's 60 minutes in 1 hour, and there's 60 seconds in 1 minute.
Right, so we go, okay, 1 hour is 60 minutes, and then we're going to multiply that by 60 again,
So that will give us
3,600
3,600 seconds.
seconds. Now, there's actually a process for doing that mathematically. Okay, so what we do is we start with what we have, and we're trying to get to what we want. Okay, so what we have is 1 hour. Okay, now always keep track of your units. Okay, I'm going to go in 2 steps. I'm going to go first to minutes. Okay, and so again, I'm multiplying by the well-chosen one. And since I want to get rid of my hours, I know my hours have to go down below, so they cancel. Okay, well, what's equivalent to 1 hour?
60 minutes.
60 minutes. So that
And
goes
hooray,
up here.
the hours
Okay.
have gone away.
Hours have gone.
Now I'm
But
in minutes.
we still need one more step, so we're going to go ahead and we're going to go from minutes to seconds. Okay, and I want my minutes gone, so I'm going to have minutes down here, and I know there are 60 seconds in 1 minute. So my minutes cancel my minutes, and what I do is the math that's left. Here's my unit that's left. I have 60 times 60 times 1, so 3,600 seconds. Okay? Same answer either way. That's just the methodical way of doing it. And that's a helpful method when we're dealing with derived units, when we have something that's not as simple or straightforward as just a single unit. So occasionally we deal with speed. Okay? And the book will give it to you in kilometers per hour sometimes. You might have a unit that you want to get to meters per second.
All right,
So
so let's do 36 kilometers per hour.
okay. Now, the easiest way to do this one is just like before. We want to figure out our conversions that we need to make. So we need to get kilometers into meters, and we need to get hours into seconds.
Okay, so I'm going to work with one unit at a time. Let's start with the top unit, kilometer. I need to change kilometer into meter. I have memorized that there are 1,000 meters in 1 kilometer.
And since
So-
we're getting rid of our kilometers, we need
Put
kilometers
that one
on the bottom to cancel our kilometers on the top.
Okay, I'm going to X those out. I even like to circle this meter. Hooray, I got meters. I don't need to worry about that anymore.
And now we've got to get those hours into seconds. Now you can do 2 steps, but we just figured out
1 hour is 3,600 seconds.
okay? And again, that hour cancels that hour, and we have to do the remaining mathematical operation.
Okay, so we got 36 times 100 times 1 on
That's
top.
1,000.
Oh, sorry, 36 times 1,000. So that's 36,000 on top.
And what units up
And
there?
I've got meters.
Excellent.
Divided by 1 times 1 times 3,600.
Oh, it's a rigged problem.
Don't think our worksheets will be this nice. So that will be 10 meters per second. Don't need to get my calculator out for this one.
All right. Okay, so that's just well-chosen one, conversion factors. Okay, just go through, work with your units, know what you, look up if this information is not there, but it's a pretty straightforward process.
Right. I'd say work with one unit at a time when you're doing derived units.
Absolutely.